All right, today's lesson very similar to the lesson right before in that almost all of our definitions and formulas look the same. So hopefully today will be less painful than yesterday. We now are working on estimating a population mean. So in 7.1 we were talking about population proportion. So mean, remember, is another value that is an unbiased estimator. So that means that our sample mean is the best point estimate for the population mean mu. One major difference in 7.2 is that when we are finding critical values, it is going to be what we call a t sub alpha over 2 as opposed to a z sub alpha over 2. So not z sub alpha over 2. If you try to do the same thing as we did with proportions, it's not going to work out the same way. So we just need to be careful that we're using t instead of z, and I'm going to show you how to do that. So we still have an area of alpha over 2 on the right tail. It's you have to do the reading to get the full description, because I think the author does a pretty good job of describing why it's called this, but it literally is called the student t distribution as opposed to the normal distribution. So we're using the student t distribution, which is why we have the t sub alpha over 2 instead of a z sub alpha over 2. The other thing that we have differently in this particular section is the degrees of freedom. So that's one of the things it's going to ask us to use when we're calculating. So usually they label degrees of freedom just by df. So what a degrees of freedom is it's the number of sample values that are allowed to vary after we impose our restrictions. In this particular section, the only thing you need to know is that the degrees of freedom is going to be whatever your sample size was minus 1. The reason for that is because if we set one of those n values, that means that everything else in the sample is allowed to vary. So that's where that comes from. In order to use a confidence interval to estimate a population mean without a known standard deviation, so unknown sigma, we have to have a simple random sample, and we either have to know that the population is normally distributed or that our sample size is bigger than 30. If we don't have one of those two criteria in number 2, and of course number 1 is easier to meet, then really we should not be constructing a confidence interval and expecting it to hold. So we have formulas here for margin of error, and we use the t sub alpha over 2 times, and then we have s, which is our sample standard deviation. So we don't know sigma, but we do know an s, and then it's square root of the sample size. We will need to make sure we know our degrees of freedom, which is n minus 1. These should look exactly like what you're used to from last section, because the only thing that we've changed are the actual statistics and parameters. So instead of p hat and p, now we have x bar and mu. So same idea, the population parameter is in the middle and our samples are on the ends. It's still the same 3 types. So this is my interval format. This one we call x bar plus or minus e format. And this guy we call inequality format. Rounding on confidence intervals here, we're going to go one more decimal place than the original data. So notice that this is different than the rounding rules for proportions. So proportions was to 3 significant digits. Here we're kind of used to doing the same thing that we do for sample mean, which is one more decimal place than the original data if we have the actual data. If we don't have the actual data and we just have summary statistics, then we'll use the same number of decimal places as the sample mean. The working backward Formulas are exactly the same, except instead of giving us p hat and e, it's giving us x bar and e. We're still taking upper plus lower divided by 2 and upper minus lower divided by 2. Finding a sample size. In this case, if we do not know our value for the standard deviation of the population, we have to use S as an estimate if we have S. If we don't, then we could, at worst case scenario, use range divided by 4. If we do happen to know the population standard deviation, then we would use a normal distribution instead of the t-distribution. So that would mean that we have to do a z sub alpha over 2 instead of a t sub alpha over 2. So there's going to be a section in the homework where it's going to ask you to decide what you should use. So should it be a student t, should it be a normal, and then find the correct alpha over 2. So when you check your answers, you don't get those right, perhaps it's because you're not using the correct type of distribution. So if we do know the population standard deviation, we would definitely use normal instead of the student t. So example 1, we're going to practice finding a t sub alpha over 2. This time we're going to use a 90% confidence interval. We used 99 in section 7.1, so we're trying to change it up just a little. So again, what this means is if 90% is the CI, then that of course represents 0.9. And remember that alpha is going to be 1 minus that. So in this case, alpha is 0.1. But we're not finding t sub alpha, we're finding t sub alpha over 2. So this is alpha, that means that alpha over 2 is half of that, so 0.05. Same definition as with z sub alpha over 2, so meaning that when we're looking picture-wise, what that's telling us is that in the student t distribution, the area on the right is 0.05. So here's my t sub alpha over 2 that I'm trying to find, this value. The area to the right is 0.05, which means that the area to the left is going to be 0.95. Now again, pay attention to the distribution that you're using. We cannot do inverse norm here because this is not the normal distribution. This is the student t distribution. So in your calculator, let me clear out the old stuff here. If we go to second distribution, you'll see that choice 4 down here is inverse t, and that's what we're going to be using instead of inverse norm. So notice it asks us for the area, and then it asks us for the degrees of freedom, which we already talked about. So when we go back over here, we're doing inverse t of 0.95, and our degrees of freedom, remember, should be n minus 1. So 100 minus 1, which is 99. So inverse t of 0.95 with 99 degrees of freedom. So type that in. Almost did 0.99. And so we get 1.66 if we round it to 2 decimal places like we do z-scores. So in this case, our t sub alpha over 2 is 1.66. All right. Now we're going to construct some confidence intervals. So in example 2, it says in a sample of 40 Chips Ahoy regular cookies, the mean is 23.95 chocolate chips and the standard deviation is 2.55 chocolate chips. Construct a 99% confidence interval to estimate the mean number of chocolate chips in all such cookies. So in this case, we have a 99% confidence interval. We are not given the population standard deviation. We are given the sample standard deviation. So because it's not population, that means that we are going to be using student t. So that means that alpha is 0.01, which means that alpha over 2 is 0.005. So when we are finding our t sub alpha over 2, again, that means that the area over here to the right is 0.005, which means it's 0.995 over here to the left. So to get t sub alpha over 2, in this case, we're going to do inverse t of 0.995. Sample size is 40, so degrees of freedom would be 39. So I can just copy this and then change it. So I went too far, 0.995, comma, and then our degrees of freedom would be 39. Close it. And in this case, we get our t sub alpha over 2 to be 2.71. So 2.71 is our t sub alpha over 2. So if we are doing our confidence interval by hand, that's what we need this t sub alpha over 2 for, because we're going to need to do x bar minus e and x bar plus e. And in order to find e, we have to have the t sub alpha over 2. Now, notice that here on our margin of error, we've got that t sub alpha over 2. And on this guy, we are going to do e equals, and so it's 2.71 times, then the rest of the formula, we have S, which is the sample standard deviation, and then the square root of the sample size. So sample standard deviation was given to us, it's 2.55. And then the square root of n would be square root of 40. I feel like you can all type that into your calculator without me actually showing it to you. You can pause it if you need to test it. But I got here 1.09. I already know what x bar is because this is my sample mean. So that means that I'm going to do x bar minus e and x bar plus e. So that turns into 23.95 plus and minus my 1.09. So if it doesn't specify, this is x bar plus or minus e format, and that would be totally fine. If it does specify, then obviously you need to actually press that in. Remember that it does say for rounding rules that you round to the same level as the sample statistics, which in this case is 2 decimal places. So 23.95 minus the 1.09 is going to give me 22.86. And then 23.95 plus the 1.09, I get 25.04. So this, or we could have this depending on what format we're using. So that's by hand. Then, I'm sure you're very excited, we also have a way to do that in the calculator. So in the calculator, it's going to be in that same menu, because I told you in the last video that we would use all the tests in that menu pretty much. So we go to stat tests, and it's going to depend because, again, I said part of your homework would be deciding whether we should use the student t, which would be in most cases, but there are a few cases where we would use the normal distribution. So if it is the student t, we're going to choose choice 8, which is for t interval. If it happens to be a case where we need to use Z, that would be choice 7. So in this case, it is student T. So we're going to be doing T interval. And when I do that in my calculator, we'll see what prompts it asks us for. So stat, tests, and in this case, choice 8, T interval. And it tells me to tell whether I have the data or whether I have the statistics. Data means you have like an actual list, which is why it says list underneath. I do not have that, so I'm going to press enter on stats. And then it asks me for X bar, SX, N, and my confidence level. So in this case, my X bar is 23.95. My SX is 2.55 because that's sample standard deviation. My N, sample size, is 40, and the confidence level that we wanted was 0.99, so I'll keep that the same. And then I press enter, and it spits out my T interval right up here at the top. Now again, make sure that we want to round appropriately, because in this case, we want to make sure that we're following all of the rules. So because it tells us to round to the same as the summary statistics, that would mean 2 decimal places. Notice that this gives me 3. So I would do 22.86, which is exactly the same as what I got before, and 25.04. Again, exactly the same as what I got by hand. Sometimes they're off slightly. In this case, they're not. So what I would write down for what I did was I chose T interval, I did stats, and then I just write down the information that I put in there. And then my answer that was spit out is the same as what I got by hand. So I should feel very confident about that. All right, last one. Example 3. Listed below are the number of years it took for a random sample of college students to earn bachelor's degrees based on data from the National Center for Education Statistics. Construct a 90% confidence interval estimate of the mean time required for all college students to earn bachelor's degrees. So we have to do that first, then we have some follow-up questions. Some of you on the homeworks keep missing the follow-up questions when you're answering things. All right, so in this case, because we have data as opposed to summary statistics, we are not going to be doing these ones by hand. If they give you data, you're definitely using the calculator. So in this case, we're going to do a T interval. Again, I do not know the population standard deviation, so I'm using T as opposed to Z. This time I do have data, and when I type things in, I'm going to have these values in a list. So you can go ahead and pause the recording. You need to go to, let me see if I can pull mine up. Here we go, to our stat edit, and go ahead and choose a list to put your values in. Remember that you can clear it by pressing clear, don't press delete, and then down. So my list 1 is now clear, and I'm ready and good to go to enter that. So go ahead and pause this and come back when you are ready to proceed after entering the data. Once you've entered the data, remember that you should always double check it. So especially here when you've got a lot of repeats, it's important that you do that. Another thing that you can quick check is that you have the right number of pieces of data. So if you count the numbers in that list, there are 20 of them. My blank one here is on 21, which means I have indeed entered 20 pieces of data. So I just kind of scroll back through, make sure I haven't put a 45 instead of a 40, or a 4.5 rather. So just making sure that everything looks good. All right. Once we have the data in our list, then we can go ahead to finding our actual tests. So stat, tests. And in this case, we're going to choose choice 8 again for T interval. But now we're going to choose data instead of statistics. When we do that, it goes back to ask us what list our data is in. Now mine is in L1. If yours is somewhere else, then obviously put it where your data is. So second one to change it to L1. You're going to leave frequency 1 always for now, so don't ever change that. Our confidence level, in this case it said 90%, so that'd be 0.90. And then scroll down to calculate. All right, now again, rounding rules. It says if we're given the actual data, we're going to round one more decimal place than the original. So in this case, our original data went to the tenths place, so we're going to go to the hundredths place. So 5.14 and 7.86. So going back over here, I chose data. I did L1, whatever your list name is. I did frequency 1 because that never changes, and then 0.9, and then the answer that it gave me is from 5.14 to 7.86. So here's the 90% confidence interval estimate. Follow-up questions. Does the confidence interval contain the value of 4 years? So that one, we would say no. The CI doesn't contain the value 4 because the lowest value in the confidence interval is 5.14. So that seems strange because there are a lot of people who finish college in 4 years. So you would think that it would at least fall in the range somewhere. It might not be, the actual mean, but you would think it would be in the range somewhere. So then the second follow-up question asks, is there anything about the data that would suggest that the confidence interval might not be a good result? So meaning, why might this not be appropriate? What do we not have that we should in this case? So think about it for a second. Scroll up. If you haven't come up with it yourself, if we have an unknown population standard deviation, we have to know that the population is normally distributed or that n is equal to 30. So we don't have the requirements. So we can say the requirements of n greater than 30 or normal distribution are not met. So if it said somewhere in the problem, the number of years it takes college students to earn bachelor's degrees is normally distributed, then that would allow us to use this. Or if the number of pieces of data we had was bigger than 30. In this case, we don't have that. So that's why this confidence interval result seems to maybe not make the most sense. All right, I think that's it for 7-2.